Hi everyone, welcome to today's science class. Today we will start chapter 6, that is combustion and flame. We will study about the process of combustion, types of combustible non-combustible substances, types of combustion also, and in the later section we will study about the flame also. So let's start. Okay, our chapter is combustion and flame. So what is combustion? What are the necessary conditions for the combustion to take place? What are various types of combustions? We will study in this particular chapter. Let's start. Combustible substances. Substances which burn in air. Substances which burn in air to produce heat and light are called combustible substances. Okay, example: wood, coal, charcoal, kerosene, petrol, diesel, LPG, liquefied petroleum gas, CNG, compressed natural gas. I hope you all know the full form of LPG and CNG now. It is liquefied petroleum gas and compressed natural gas. Okay. CNG is also known as the clean fuel. Okay. So in images also you can see the combustible substances: wood you can see, coal you can see, and LPG you can see, and kerosene oil is also shown over there in the lamp. Okay, so let's start to study about the combustion. The chemical process in which a substance reacts with oxygen to produce heat is called combustion. Okay, in the process of combustion, the thing is the substance will react with the oxygen and it will produce heat. In the combustion, the substance which undergo combustion is called combustible substance. It is also known as fuel also, and we studied about some examples of combustible substances: wood, charcoal, LPG, CNG, LPG, petrol, diesel. Okay, sometimes light is also produced during combustion, either as a flame or as a glow also. So the air is necessary. Air is so air is necessary for the combustion to take place. Okay, let's start. Let's study why air is necessary for burning. You can see, burn a candle and do one thing. Put this candle in an in a glass, visible glass, and then what you will see? You will see when the glass is placed inverted over there, after some time the candle will not be blowing, candle will be off, or there will be no light produced. And if you will do one thing, you can also consider the situation given in this particular slide also. Lighted candle on a table, put a glass chimney over the table and rest it for a few wooden blocks in such a way so as to air can enter the chimney. You can see in the first pic over there, the air is allowed to enter in the chimney. Observe what happened to the flame. Now remove the blocks and let the chimney rest on the table. Again observe that. Then put a glass plate over the chimney. Okay. Observe the flame again. Now the candle burns freely. In picture A, you can see, because the air is entering from the below, the candle stops burning because the air does not enter the chimney from the below. Third, the candle does not burn because the air is not available. This shows that air is necessary for burning. Presence of air is mandatory, or it is a necessary condition for the combustion to take place. That the air must be present over there. Next is ignition temperature. The minimum temperature at which a substance catches fire and burns is called its ignition temperature. Okay, got it? Ignition temperature it is called. A substance will not catch fire and burns if the temperature is lower than its ignition temperature. Different substances have different ignition temperature. The ignition temperature of kerosene is less than the ignition temperature of wood. The substance which have very low ignition temperature can easily catch fire with a flame called inflammable substances, and the examples are petrol, alcohol, LPG and CNG are the examples of some inflammable substances because they can catch fire at a very low temperature. Okay. Conditions necessary for combustion to take place. Conditions necessary are combustion for, first is fuel must be present over there. Definitely fuel will not be over there, then it doesn't make any sense of having other conditions appropriate for the combustion to take place. Air, this to supply oxygen. The supply of oxygen must be there. If there is no supply of oxygen, then obviously the combustion will not take place. We have studied the same uh, in a point 1 or 2 points ago. Okay. Third point is heat to raise the temperature beyond the ignition temperature. Okay. A substance will not burn without one or more other conditions of these. So these are three necessary conditions for the substance to burn or for the process of combustion to take place. Okay, if any of them will be missing, then the process of combustion will not be there. It will not take place. How do we control fire? Okay, the conditions necessary for producing fires are fuel, air, heat, okay, ignition temperature. Fire can be controlled by removing one or more of these conditions. We can remove the fuel, you can see. We can cut the supply of air. We can reduce the temperature. Okay, a fire extinguisher cuts off the supply of air or brings down the temperature of the fuel or both and controls the fire easily. Got it? Methods of controlling fire. First is by using water. Water is the most common fire extinguishers. It can be used only when materials like wood, paper are on fire. Water we cannot use if the fire is caused in electrical equipments are on fire, because the water conducts electricity and it can harm those persons to it can harm those trying to put out the fire also. So water cannot be used to put out the oil and petrol fires because they float on the water and continue to burn, because both petrol and oil are lighter in density than the water, so they will float on the surface and the fire will continue over there. By using carbon dioxide. Carbon dioxide is the best fire extinguishers to put out the fire caused by inflammable materials like oil and petrol and electrical equipments. Carbon dioxide is heavier than air and it covers the fire and cut off the supply of oxygen and puts out the fire. Carbon dioxide is stored at high pressure as a liquid in cylinders. Chemicals like sodium bicarbonate, baking soda, potassium bicarbonate produce carbon dioxide near the fire. Okay, got it? We can use either water we can use or carbon dioxide we can use. Both will help out in controlling the fire, but water is having limitations. We cannot use water if the fire is caused due to the fire is caused due to if the fire if the fire is caused due to electrical appliances or due to oil or petrol. Okay, let's move to further. Next is types of combustion. There are three main types of combustion. One is rapid combustion, second is spontaneous or continuous combustion, third is explosion. Rapid combustion is a combustion in which a substance burns rapidly and produces heat and light with the help of external heat, for example burning of LPG, liquefied petroleum gas. Okay. Next is spontaneous or continuous combustion is the combustion in which a substance burns continuously or spontaneously and produces heat and light without the help of external heat. Got it? Phosphorus burns spontaneously at room temperature. Next is the third type of combustion. It is explosion. Is a combustion in which a substance burns suddenly and produces heat, light, and sound with the help of heat or pressure. Explosion of crackers on applying heat or pressure. Okay, got it? I think all the three types of combustions you understood by examples also. Rapid combustion, burning of LPG. Spontaneous combustion, phosphorus burns spontaneously at room temperature. Explosion of crackers on applying heat or pressure. Now flame is a zone of combustion of a combustible substance. The substance which vaporizes during burning produces flames. Substances which vaporizes during burning produces flames. Examples you can see kerosene, wax, etc. Substance which do not vaporize during burning do not produce flame. For example coal and charcoal also. Got it? Types of combustion we studied. You can see in the images also. Rapid combustion, flame of LPG. Spontaneous combustion, continuous emission of heat and light. Explosion, you can see generally the explosion is seen on the festivals, especially Diwali and Holi, or during the marriage or other functions also. So rapid combustion is in your kitchen also. You can see the cooking of food over LPG. Then the LPG is an example of burning of LPG is example of rapid combustion. Structure of a candle flame. Hottest part, outer part, it is outer zone or blue, non-luminous zone or complete combustion you can call it. Then moderately hot zone, middle zone, yellow or luminous zone. Luminous means which is visible to us. Partial combustion will take place in this zone. Least hot zone, it is the inner zone. Black or unburnt wax vapors over there. So you can do one thing, dear students. You can draw the diagram of the candle and you can highlight all the three parts and you can write or explain these three parts, because the maximum times the question in 3 marks came. Explain the different zone of a candle with its diagram. Okay. Structure of a candle flame. Candle flames has three main zones. They are outer, middle and inner. In outer zone, complete combustion of fuel takes place and the color of the flame is blue, and in the is the hottest part of the flame. It's a non-luminous part of the flame. In middle zone, partial combustion of fuel takes place and the color of the flame is yellow and is moderately hot part of the flame. It is a luminous part of the flame. In the inner zone, there are unburned vapors of the fuel and the color is black and the least hot part of the flame. So you are advised not to touch any of the part of the flame. So avoid touching. It can cause or it can produce harm or injury to you. So just study the different parts of the candle. Okay, you can burn a candle, but you will do this in the supervision of your parents only. types of fuel. There are three main types of fuel: solid, liquid, and gaseous fuel. Solid: wood, coal, and charcoal. Liquid: kerosene, petrol, diesel. Gaseous fuel: CNG, LPG, biogas, and hydrogen also. Okay, got it? Solid, liquid fuels you can see by the images also. Characteristics of a good fuel. The main characteristics of a good fuel is it is readily available. The fuel we will consider only good if its availability is in abundant. Okay, it is in sufficient available in sufficient amount. It is very cheap. Okay, is easy to store and transport. Easy to store and transport, definitely, then and only then it will be a very good fuel. Burns at a moderate rate, it will not burn as fast or as slow, so it will take some time to burn. Produces a large amount of heat, definitely if we are burning something then we will expect the amount of heat produced will be sufficient. Do not leave behind any undesirable substances. It will, after burning, it will not leave any ashes. It will complete combustion. If the complete combustion is taking place in this in the fuel, then it will be considered as a good fuel. And last but not the least is, do not cause any type of pollution. Either it is sound pollution or it is noise pollution, okay, or it is air pollution. Got it? Calorific values. Now you can see the calorific value. Maximum times the question will be asked in exams, which of the substance is having highest calorific values. You can see hydrogen is having the highest calorific value among all the fuels. It is the amount of heat energy produced on complete combustion of 1 kilogram of a fuel. 1 kilogram of a fuel, the calorific value of a fuel is expressed in terms of kilojoule per kilogram. Kilojoule per kilogram. Got it? Now, the harmful effects on the environment due to burning of fuel. Fuel like wood, coal, petroleum release unburned carbon particles which cause respiratory disease like asthma. Second is, incomplete combustion of fuel releases carbon monoxide gas, which is very poisonous gas, which can cause death also. Okay. Third is, the burning of most fuel releases carbon dioxide gas, which causes the rise in temperature of the atmosphere. This is called global warming. It causes melting of polar ice, rise in the sea level, and flooding of coastal areas. Okay. The last is, the burning of coal and petroleum releases oxides of sulfur, nitrogen, which dissolves in rain water and forms acid rain. Okay, it is harmful for crops, soil, and damages the buildings also. Okay, so avoid avoid wasting fuel, actually, not using fuel. Avoid wasting fuel. Use it only and only when it is necessary. Okay, so dear students, thank you so much for listening me patiently, and this is very much interesting and informative topics or chapter. So try to do one thing, revise it, and try to note down all the important points discussed in the video. It will definitely be helpful for you in your upcoming exams. Make a sound understanding of the concepts. Make a sound understanding of the concept, and definitely it will help you in a more or much better way. Thank you, dear students. Thank you so much. Thank you. Bye bye.